One of the most important sulci in the human brain is the central sulcus. And one might imagine when we look at the human brain that it ought to be easy to determine which one is in fact the central sulcus. Sulci, of course, are the term we use for the spaces that we see in the surface of the cerebral hemisphere. So one interesting point about the central sulcus is that sometimes it can be very difficult to find in a human brain because the brains often don't look like the simplified figures we often see in textbooks. But there is a way to find the central sulcus that's foolproof. And to do so, I have to look at a specimen that's been cut right down the midline along the mid-sagittal plane. So I'm going to put aside our whole brain and show you a hemisphere that's been sectioned in the mid-sagittal plane. So here we have a hemisphere, and this broad structure of white matter here is called the corpus callosum. And just above that corpus callosum is a gyrus called the cingulate gyrus. And if you would, I want you to appreciate the sulcus that forms a space just on top of the cingulate gyrus. This is called, conveniently enough, the cingulate sulcus. So we follow this sulcus back from the front of the brain towards the back of the brain, and we find that just past the middle of the hemisphere, there's a point where this sulcus makes a sharp upward bend. That's called the marginal branch of the cingulate sulcus. Now, if we identify that marginal branch of the cingulate sulcus and look for the very first sulcus that intersects the midline, I know that this will always be the central sulcus. So I'm going to just gently put my wooden stick in that space and then turn the brain around, and we'll see if this is in fact the central sulcus. So now, as we look at the lateral surface of the brain, we've identified the central sulcus. And the other features that help us know for certain that it's a central sulcus are the fact that it's a long sulcus that makes a lazy S-shaped bend on its way from the dorsal midline down towards the lateral fissure, which is a large space separating the temporal lobe and the frontal and parietal lobe. Now, to see the central sulcus even better, I'm going to gently pull away some of this tissue that's covering the surface of the brain. This is called arachnoid, and the arachnoid is a tissue that helps to create a buffering space over the surface of the cerebral cortex. Underneath the arachnoid in life is perhaps a millimeter or two of cerebral spinal fluid. So as I tease apart this tissue, we can see the full length now of the central sulcus, all the way from its medial terminus along the dorsal midline to its lateral terminus, very near the lateral fissure. It's worth noting how the body is mapped out along the banks of this sulcus. The gyrus that forms the anterior bank is called the precentral gyrus, and this contains the motor map of the contralateral body. The gyrus that forms the postcentral structure is called the postcentral gyrus, and it contains the somatic sensory map of the contralateral body. And there's a beautiful mapping of the body from the midline to the lateral fissure, beginning along the medial surface of the brain, where the central sulcus intersects the dorsal midline of the hemisphere. This is a structure where the precentral and postcentral gyri come together to form a lobule, which is just a word that means a larger gyral structure. This lobule is called the paracentral lobule because it contains the medial termination of the central sulcus. The paracentral lobule is where we have the representation of the contralateral foot. This is the right hemisphere, so this is where the left foot would be represented for motor control and for somatic sensation. And as we progress from the paracentral lobule onto the dorsal and lateral surface of the brain, we ascend that body map from the leg up towards the hip region and then into the trunk. And then just where we see this distinctive S-shaped bend in the central sulcus, that's where we know that our body map is progressing from the trunk to the forearm and then eventually into the region that represents the hand. Where we see this prominent S shape in the central sulcus, that's the representation of the contralateral hand, again with motor control being mapped to the precentral gyrus and somatic sensation in the postcentral gyrus. Now this body map is exquisite, and it's a map that perhaps not Michelangelo would have depicted, but perhaps Pablo Picasso, since there's a bit of a cubistic break in the human form along the central sulcus just below this S shape. Rather than continuing on with the representation of the hand and the digits, just below this S shape we have now representation of the face. So that the face now is represented for motor control in the precentral gyrus and somatic sensation in the postcentral gyrus just below the tips of the fingers. And the representation of the face carries on down to the lateral termination of the central sulcus.